Okay. So just like addition and subtraction are inverses, and multiplication and division are inverses, trig has inverse functions too. We've seen that a little bit here and there. This is the official lesson on it. But we get to see what the graph looks like, and we have to kind of, there's some places where we have to talk about the domain and the range a little bit and some validity on them, okay? So we do half of this today, half of this tomorrow. That's it. Then we do study guide, and test on Friday. Okay? All right. Test on Friday. You don't like tests on Fridays? Oh, you like tests on Fridays.
You always do it like on Wednesdays.
I like to do it in the middle of the week because every other teacher gives a test on Friday.
Yeah.
Yeah. So then you don't have 6 tests on Friday, right? So that's why I try to pick a middle of the day of the week. This time it just happens to land on Friday. Okay. So, let's talk about these things. So here's the deal. And this is a little bit weird, okay? This is talking, do you have to write anything down there, or is it all there for you? It's all there. Okay, good thing it's all there, because it's the understanding piece of it. So, basically, in order to, we have this, you can write it one of two ways. It can be either written as sine to the -1, okay? That's sine inverse, or we write it arc sine. Your book takes an arc sine approach. Sometimes they'll throw that in there, the sine to the -1. They're interchangeable, okay? So if you have to have the sine of something, in order to get rid of the sine, we take the arc sine of it. In order to get rid of the arc sine, we take the sine of it, and we have to do that to both sides. So what this thing here is saying is, in order to get rid of the arc sine, if I took the sine of both sides, it would cancel, so that's how they got sine of y equals x, okay? So that, and the same thing works for all of the, all of the trig functions. We're going to focus on sine, cosine, and tangent for the most part, but it does work for all the other ones as well. The domain is basically the domain that we would have on all of our regular graphs, okay? But the range is a little bit different. So here, I'm going to do to the best of my ability, explain the range. Okay, so if we think about our unit circle, okay, and we think about that, we know that all are positive here, sine is positive, or tangent is positive, and cosine is positive, okay? The idea is that the range is valid where there is one positive value and one negative value for each function, okay? But it has to be continuous. So, I know that cosine's valid there, right? If I'm talking about the sine of a function, I know sine is positive here and negative here. So for sine, I'm only going to come up with answers that are in quadrant 1 or quadrant 4. That's what this range is telling us. From -π/2 to π/2, it's valid. Okay? For cosine, I know cosine is positive here and negative here. And that's the only place on there where it's continuous and would work like that. So sine is valid from 0 to pi. Okay, so I'm only going to look in quadrant 1 or quadrant 2 for answers. Tangent is the same as sine. In quadrant 1 or quadrant 4, it's negative, and in quadrant 1, it's positive. So I can go from -π/2 to π/2. And so that way it's continuous, and I get one positive answer and one negative answer. Okay? All right. There's the pictures of what they look like. We will never graph it by hand. Okay? This is more for your information. All right? So that's what they look like. It's like part of the curve tipped on the side, right? All right, so we're going to find the exact value of each expression without using a calculator. So here's where your unit circle comes in. So everybody has their unit circle in there, right? We're going to go with radian measure today, so we're going to do the pies, okay, not the degrees. We're looking at arc sine, and I just told you we talked about the quadrants. Arc sine, we said, is valid in quadrant 1 and quadrant 4. Is sine the x value or the y value? It's the y value. So you need to look in those two quadrants and look for the y value to be -1/2 and give me the radian measure. Okay. So we're thinking it's 11 pi/6. We're going to add to our unit circle right now. Okay? So on your unit circle, you have 11 pi over 6. Let's see. This is that 7 pi over 4 right there?
Yeah.
And 5 pi over 3. Here's the problem. Our domain is from negative pi over 2, or our range is from negative pi over 2 to pi over 2. I can't give an answer that isn't in between there. So on this one here at 3 pi over 2, right next to, write a comma. So you have 3 pi over 2. Write a comma. It's also negative pi over 2. This one here is also negative pi over 3, and this one here is also negative pi over 4, and this one is also negative pi over 6. So when we're doing the inverse trig, you're going to use your negatives. Okay? So instead of 11 pi over 6, what are you going to tell me? Negative pi over 6. And I just let you write that on your unit circle, so you're allowed to have that during the test. Okay? We're not taking your unit circles away from you yet on the test. Okay? We'll get there, but not yet. Okay? All right, we good? All right, I'm going to leave it up there for another minute. Make sure everybody has it written down and edited on their unit circle. Not a lot of work, right? I did some scribbling, and then I did most of the work off the unit circle. Yes? How I got the negative pi over 6? Okay. So my answer has to be in either quadrant 1 or quadrant 4 for sine. Sine and tangent are those. Cosine is 1 and 2. Okay? So I know that sine is my y value. Okay, so I look in these two quadrants for the y value part of my coordinate that's negative 1/2, and that appears at negative pi over 6. So that's my answer. So I'm looking for the angle measure today, not the coordinates. All right, Ivan? Okay, let's do another one. It'll hopefully make more sense after doing 2 of them. All right, there's our sine inverse, means the same as arc sine. So which quadrants am I allowed to look in for sine? 1 and 4. Okay, so on your unit circle right now, everybody's looking at their unit circle. Do we look at the x coordinate or the y coordinate? The y coordinate. So look for your y part of your coordinate to be square root of 3 over 2. What radian measure does that happen at? Pi over 3. Are we seeing it now? Okay. All right, looking at the next one. I don't know why they're all sines today, but they are so far. Is 2 on your unit circle? No. So we would write down that this one is undefined. It's a D and E. Undefined because it's outside of the domain. I'm going to guess that happens somewhere in the homework, so if it's here, it's sine, it's probably cosine in the homework, right? All right, example 4. Okay, so let's talk about cosine. Cosine, it's in which 2 quadrants? What did we say earlier? 1 and 2 is where I'm allowed to look for cosine. Everything else is 1, 4. Cosine is 1, 2. Because it has to be a positive and a negative together. So look in there. Is cosine the x value or the y value? X. So at which radian measure is x squared root of 2 over 2? Pi over 4. And again, we're not doing this quadrant. We can only use 1 and 2. And I'm going to go back and show you where that was at. Okay? So it's from the definition. See how this is the definition of the inverse trig? It says that I'm only allowed to go between 0 and pi. Does that make sense? And it's not, I'm not going to give you any more explanation that you need a positive and a negative, and that's it. We get cut off. Okay? Because that's the rule that they give us. All right? We're not going to try to further explain the rule. We're just going to go with the rule. Sometimes that happens. All right. Let's look at this one here. I have to be in which 2 quadrants for cosine? 1 and 2, and I could be on the axes. So am I looking at the x coordinate or the y coordinate for cosine? X. So at what radian measure is the x value negative 1? Pi. Very good. All right. Gets a little bit trickier with tangent. Okay? So first of all, which 2 quadrants do I get to look in? 1 and 4. Okay, so I'm only looking at 1 and 4. Because I know that tangent is positive in quadrant 1 and negative in quadrant 4. And they're next to each other. Okay? Alright. I can't just read a tangent out of my coordinates, right? I have to know the sine divided by the cosine. Technically, what's underneath the 0? A 1, right? So I know that it's always a 1 on the bottom if there's nothing there. So my sine has to be 0 and my cosine has to be 1. So aren't I looking for the coordinate 1, 0? Where is that? What radian measure does that take place at? Okay, I like the answer, but we're going to adjust it a little bit. Remember, you have to be between negative 2 pi and 2 pi. Is 2 pi in between those two numbers? What is in between those two numbers that's the same as 2 pi? 0. So we would use 0. So you're going to default to 0 today. Okay, no 2 pi answers. All right, let's take a look at the next one. Okay. All right. Tangent has... So which two quadrants am I looking in? 1 and 4. Okay, those are the only two I'm allowed to look in. I need my sine over my cosine to be equal to negative 1. So which one of the quadrants am I going to land in if I have to be negative? 1 or 4? We're going to land in 4. If it's going to come out to be negative 1, don't I need the sine and the cosine to be the same number? What radian measure are they the same number but opposite signs? Yeah, negative pi over 4, right? Because this one, sine is negative square root of 2 over 2, and cosine is square root of 2 over 2, so those would reduce to negative 1. Okay, and again, we're using the negative pi's, not the 7 pi over 4. All right. Now it looks like we're using the calculator. Awesome. All right. The next example throws us into the calculator. So, what does I tell you up here your calculator should be in? Radian. So let's make sure that we're in radian mode. Okay, so let's all check radian mode on our calculators. So I'm going to get rid of whatever's there. I know Zero Period is using them for some stuff today. Alright, I'm going to go home actually and get my mode changed. Or double check my mode. Should be in radian. Was this the class period we talked about the display digits, the float? It must have been second period. This here, you guys, why we leave an insane amount of numbers there. So some people were having issues with rounding, and it was down. It was at might have been on fix. It should at least be at float, so then you can see it. Calculus keeps it at float 6 because of the accuracy we have to have for our answers. Okay. If you change it on them, that's fine, but we want to make sure you're at least 3 decimals. You might want to go 4 to make sure it's rounding correctly. Okay, but you don't have to change it. You can leave it at float 6, and that's fine. Okay, I know for some of us it gets annoying. All right, go okay. You'll have to keep changing it though, because calculus will keep changing it back. All right, so we're gonna do arctangent. So we're gonna go on our calculator where it says trig, and I'm gonna use the tangent inverse symbol. So the tangent to the negative 1. And then we're going to type in negative 8.5. Or sorry, 8.45. And hit enter. That's what you're going to write down, negative 1.453. Is there any work I'm showing? No, I don't even need to leave space for you to show work on the test, right? So negative 1.453. Alright, the next one is sine to the negative 1. So sine inverse, type it in exactly the way it looks. I'm going to let you try it. So everybody try it, and then you're going to tell me what you get. Alright, what are we getting? 0.2472. So just let's stop at 7? Yeah. Okay. Try that one. Arc cosine. So do cosine inverse of 2. What came up? Undefined, because it's outside the domain, right? We could have probably done it without the calculator, but I wanted to make sure you saw what happened in the calculator. All right. Let's try 11 and 12, and then we're gonna be you get to do some you get to work on your assignments. Okay. So it says use inverse trig function to write theta as a function of x. So all I'm gonna do is I have to figure out if it's sine, cosine, or tangent. So what I have the opposite and the adjacent. So is that sine, cosine, or tangent? So, but in order to write it in terms of theta, we would go theta equals arctangent of the opposite over the adjacent. That's what they're going for on that one. You could also write it as tangent inverse, your choice. Both of those are acceptable answers. Okay. All right. What parts do I have on example 12's triangle? Oh, it's different on yours?
Yeah. The x plus 4 is on the bottom.
The x plus 4 is on the bottom of yours?
Yeah.
Interesting. Is the 3 in the same place?
Yeah.
Okay, move your x plus 4 because I want it to be different, because if not, then it's tangent again. So move your x plus 4 to where my x plus 4 is. Okay? All right. So I have opposite and hypotenuse. What's opposite and hypotenuse? Sine. So we'd write theta equals the arc sine of 3 over x plus 4. Or sine inverse of 3 over x plus 4. Technically, it should probably be in parentheses. I'm being kind of sloppy. All right. That's it for today. Can we handle it? I hope so. It should be easy. Okay. All right. So I'm gonna give you I need to post the assignment, right? I'm gonna post it real quick. You guys can grab books. All right, it should be there if you refresh.